Evaluating limits by canceling. If we wanted to evaluate this, with our old method, we would have just substituted in 1. But when we substitute in 1, we get 1 minus 1 over 1 squared plus 2 times 1 minus 3, which is negative 0 over 1 plus 2 is 3 minus 3 is 0. So this doesn't give us an answer. It doesn't tell us whether it's undefined or 0 or 1. When we have 0 over 0, we call this indeterminate form. And indeterminate form, we need to use other methods in order to solve this. The way that we can is using this rule of limits, which speaks about removable discontinuities. Removable discontinuities, let me type that out. Removable discontinuity is equal to a whole. We've talked about this in terms of rational functions before, but the limit, when we take the limit as x approaches a of something like this, we are allowed to cancel out these factors even if x is approaching a, meaning that this would become a minus a over a minus a. We can do this if the exact same factor is listed in the numerator and denominator. We can cancel that out. So over here, what that would look like is, well, this is the limit as x approaches 1 of negative x minus 1 over, factoring this, we have x plus 3 times x minus 1. We can cancel those factors out, leaving us with a 1 in the numerator. And now we have the limit as x approaches 1 of negative 1 over x plus 3. And when we substitute in 1 here, now we can get out a value, 1 over 4. So negative 1/4 is the limit. Even though when we plugged in 1, it doesn't get this value. As we plug in things close to 1, we will get out negative 1/4. And this is how we can do it without a table or a graph. So let's do this with a few other examples. First, when we plug in 2, we get 0 over 0, so it's indeterminate form. So we can factor the numerator and denominator. X plus 4, x minus 2, x minus 2. Cancel those, and we get this is equal to the limit as x approaches 2 of x plus 4. And substituting in 2 gives us 6. So that's the limit. Here, we factor both pieces. The numerator is already factored. The denominator is x plus 5 times x plus 4. Canceling out the x plus 5s, it leaves us with the limit as x approaches negative 5. Plugging in negative 5 gives us 1 over negative 5 plus 4, which is 1 over negative 1, or negative 1. Here's a more interesting one. We can't directly cancel things out here, but we can, say, get the denominator to be something simpler. If we write this as 2 over 2 times 2 minus 2 plus x, minus 2 plus x over 2 times 2 plus x. This becomes, the limit as x approaches 0 of x over, these we can combine, 2 minus 2 is 0, so we're left with negative x over 2 times 2 plus x. Dividing these, the x's cancel, and then we have 1 over this fraction, which is the same thing as negative 2 times 2 plus x. And now we can just substitute in 0 because now that we don't have 0 over 0, we don't have indeterminate form, 0 can just be substituted in. So negative 2 times 2 gives us negative 4 is the limit. Thanks.